Hello again. So this is an overview for the second module in CMSC 437, the machine learning course. So in the second module, as you can see on the module page, we will continue our study of machine learning with supervised learning algorithms, particularly the very popular supervised method called linear regression and the associated logistic regression for classification algorithms. So the lesson objectives are, so we will start with introduction to supervised methods, right? So supervised methods work with label data. That means the data that you work with has annotated target, also called dependent variable. And we will study how what is involved in the training activities, training or fitting the model to the data. And part of that is evaluating the performance of the supervised methods. So when you train on the training data, part of that is you have to evaluate the performance of the model using an independent set. So supervised method in general, you would have to have training samples and test sample when you look at from a machine learning perspective. Okay. So we will study two methods, as I said, linear regression and logistic regression. The two methods are the same in the assumption, in the underlying linearity assumption between the target variable and the independent variable. So linear regression deals with numerical targets. That means your variable, your target variable is numeric. So you're doing regression, you're predicting numerical values. It's a very powerful method that works with simple assumption of linear relationships, although in reality, most complex problems don't have that linear relationship. But for most problems, linear regression performs really well. And so that would be linear regression. Logistic regression is an extension of that. By the way, in linear regression, we have simple and multiple linear regression. Simple is when you have a single variable, but for most problems, you will be dealing with multiple independent variables. So there are those two types of linear regression. For the logistic regression, as I said, is an extension for classification problem where you have the category called dependent variable. It's not numeric, but category. That means with classes or categories. The task in logistic regression is to be able to predict the outcomes of those classes and categorical variable. Again, works with similar linear assumption, or linearity assumption. Now there are two types in logistic regression. One is for binary classification. That means your target variable has only two outcomes, like a yes or no outcome. But you can also use extend linear regression for multi-class problems where you have multiple categories in your dependent variable, and that is called multinomial logistic regression. Okay, so that is the second part of our study. Well, actually the third. So we will study the basics and principle of supervised learning, how you know the principle of fitting, what is involved in the fitting activities, and then we will perform evaluation of the model based on the training data, based on test data. And then we move on to linear regression, which is an application for predicting numerical values. And then we'll study logistic regression, both binary and multinomial logistic regression for classifying or predicting classification problems. And then, so we will experiment with a Python code to actually fit a model, evaluate the model performance, and we'll write a report on our study, our experiment. Okay. Obviously, that part of that is model evaluation, and you'll get into what are the appropriate metrics to evaluate the performance of different supervised models. There are different methods for regression and classification problems. So part of your fitting, part of your experiment is to actually perform or employ different metrics to evaluate the performance of the training model. So similar to what we did in Module 1, the reading materials on supervised learning and model evaluation. That is the first part of the reading material that you see on the module page, and another set of reading materials for linear regression, and then we have additional reading material for logistic regression. This week is a bit involved, but you have 2 weeks to complete the content of this module. And we have some YouTube videos for each topic for all the 3 topics that we will be looking at here. And as for assessment, so there's 1 quiz that covers all the materials on supervised learning and was linear and logistic regression. And as I said, the assignment would be fitting a model on logistic regression. So there is a recommended data set that you will find from Kaggle page. This is recommended. If you have preferred data set that you're familiar with, you're welcome to use that as well. This is just a recommendation. So you would have to review theoretical background and then through the reading material. And you would write a code and fit a logistic regression model for the particular problem that you chose, and write a report on the main activities, the tuning of the parameter selection, and also evaluation of the model. Linear regression and logistic regression, they have additional methods to evaluate the performance of the model, particularly to validate the linearity assumption that is inherent in these methods. Okay, so that is what we will be studying in Module 2. Okay, thank you.